Google runs millions of lines of Python code. The front-end servers that drive YouTube.com and YouTube's API are primarily written in Python, and they serve millions of requests per second. On this episode, you'll meet Dylan Trotter, who is working to increase the performance and concurrency of these servers powering YouTube. He just launched Grumpy, a Python implementation based on Go, the highly concurrent language from Google. This is Talk Python to Me, recorded January 12th, 2017.
I'm a developer in many senses of the word, cause I make these applications, but I also use these verbs to make this music. I construct it line by line, just like when I'm coding another software design. In both cases, it's about design patterns. Anyone can get the job done, it's the execution that matters. I have many interests, sometimes it can
Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm, and follow the show on Twitter via @talkpython. This episode has been sponsored by Hired, and as a new sponsor, PyImageSearch.com. They're announcing a Kickstarter campaign called Deep Learning for Computer Vision with Python, launching on Kickstarter right now. Thank both of these companies for supporting the show by checking out what they have to offer during their segments. Dylan, welcome to Talk Python.
Thanks. Nice to be here.
Yeah, I'm really excited to talk about Grumpy, actually. Grumpy, your Python project is going to be fun.
Yeah, it's been pretty exciting couple weeks since the release. So yeah, I'm excited to talk about it too.
Yeah, it's definitely gotten a lot of attention in the open source world on GitHub, and we're going to dig into a lot of the details behind it. But let's start with you and your story. How did you get into programming in Python?
I started programming, I guess, when I was in high school. I took like a intro programming course and kind of got the bug. And I just kind of took it from there. I was really into like programming little games and stuff like that back then. I did not do CS in university. I actually did physics, but I continued to work on programming in my own time a lot. And during university, actually, I got a gig at a sort of summer gig at a software company, and that gave me a leg up when I graduated, which was pretty lucky. And so I got a job at a visual effects company doing software there. So there was a bunch of different things, like a lot of sort of proprietary languages for the different packages, but Python sort of came out as a front runner in terms of integration with different visual effects packages and stuff like that. And so that's where I started to dig into Python, especially not so much on the sort of like effect side, but more on the pipeline data management kind of side of things. So there's a lot of asset management and stuff going on in visual effects studios, and Python's great for that sort of stuff.
Yeah, that's really cool. I did a whole episode on Python and like game development studios and movies and production and stuff. I was really surprised how much Python glues all the tooling together for those folks.
Yeah, it's really deep in there. In fact, when I was working in that area, that's when Python sort of started to come to the fore. And so like Maya, which is a big like modeling and animation package, built Python integration around that time. And Houdini is another one, similar use cases that integrate, or actually, I think from pretty early on, Houdini had Python integration. So yeah, it sort of became the de facto visual effects integration language.
Okay, yeah, very cool. And I think that's only growing. It seems like there's a couple areas where Python is sort of past critical mass. It's kind of like a black hole now. It's just sucking everything into it.
Totally.
Yeah, and that's a good thing. So you don't do visual effects anymore, although you kind of work in the video world these days. Why don't you tell everybody what you're up to?
Yeah, sure. So I'm at YouTube now. I started there about 7 years ago. It was a kind of a big shift for me. Visual effects was a fun environment, but it was always kind of a dream to work at Google and stuff. So I took a gig at YouTube, and I've worked on a number of different teams there, actually. I've worked on sort of user-facing features. I was on the channels team for a long time, working on YouTube channels and stuff around that. And eventually got more into the infrastructure side. And so now I'm working on what's called the application infrastructure group, and our team specifically looks after the application server that serves youtube.com and YouTube APIs and those sorts of things.
Excellent. So when we're all watching various things on YouTube, be it cat videos or something educational, we have you to thank for keeping those servers running.
Yeah, well, me and a lot of other people. Yep.
Yeah, I'm sure. Well, I'll thank you individually. So yeah, awesome. Yeah, that sounds like a really fun place to work. Where's YouTube? Where's the center of the universe for YouTube? Is that Mountain View or somewhere else?
San Bruno actually is where the main YouTube campus is. So there's a few different offices around the world, but the biggest sort of geographical concentration is in San Bruno. So there's a few buildings there that are YouTube.
Okay. Yeah. Nice. That sounds like so much fun. So Python actually plays a really important role at YouTube these days. Let's talk about how it's used now and then how that kind of came to be.
Sure. Yeah. So Python is what is running the main application server and a lot of the application code for the YouTube front end and for that serves like the website and the API serves APIs that, service your phone and those sorts of things. So it's sort of like the gateway for most user traffic.
Right. And then maybe the Python code branches back into all sorts of Google services behind the scenes that are in a variety of technologies or something like that, right?
Yeah, there's a lot of different technologies and servers involved in the whole thing. Yep.
Okay. So YouTube wasn't initially a Google creation, right? It was created by some other folks.
It was founded in 2005, I think, by three guys, the one of which was still there when I joined in 2009 was Chad Hurley. I think at the time he was the president or something. He left shortly after I joined. But yeah, they built it in 2005 and it gained a lot of traction really early on. And I guess Google took an interest at some point in 2006 and ended up buying YouTube in November 2006.
Yeah, I'd say that was a great move for them because it's such a central part of the internet. I feel like it had YouTube, the idea was something that a lot of people probably had the idea. It was a thing that clearly should exist. But when you think of the infrastructure and the bandwidth costs and just the actual act of creating such a huge video network, seems prohibitive, but once it came into existence, I guess Google jumped on it. That's cool.
I actually remember thinking what a simple idea it was and how like it seemed so crazy at the time that I think the acquisition cost was like 1.6 billion or something like that. And I remember reading about that and I was like, good Lord, like, you could, how is something so simple worth so much? But now that number seems so quaint, like compared to recent stuff. So
yeah, of course. I mean, a lot of companies go through the thinking, it's easy to go through the thinking of you could have just built that yourself.
Yeah.
Right.
Absolutely.
I mean, Facebook bought Instagram for like an insane amount of money. And that's like a team of 12 people, right? For whatever it was, like 19 billion or something. They could have easily paid 12 people to build another Instagram, but it's also got people's interests. It's got the users. It's got the momentum. And that's the thing I think people buy.
Absolutely. That's what you're paying for.
Yeah. But they didn't write it in Python at first, did they?
No, the first implementation, I believe, was PHP. And I don't think that lasted very long. I think most of that was rewritten in Python pretty early on, well before I was there.
Sure. And I suspect the way YouTube looks today, with the growth of cloud computing and all the different APIs and services, is probably super different from what you guys got back in 2006, right?
Yeah, I think, the company's grown a lot. The use cases have grown a lot. It's just, it's kind of night and day. It's when I first joined, everyone was kind of in one floor of one building. And since then, there's distributed all over the world. And so, yeah, it's changed a lot.
Sure. Wow. Okay, so that brings us to today, to YouTube, and what this project was this something that you created, this project called Grumpy? Or where did this come from?
Yeah, I talked about some of the challenges we were having with, running Python at scale and on the blog post. And basically, there's a few different aspects that affect our ability to run, that many Python servers. The C Python runtime, well, it's really great and it's highly optimized and it does a lot of things really well. For our use case, it's never really been a focus for C Python as a project. We thought, maybe it makes sense to rethink how the runtime is built with a focus on concurrency and running large server applications.
Yeah, and you guys are not the first people to have this idea of, well, maybe we could replace the C Python runtime interpreter with something else. There's like Jython, there's IronPython, there's PyPy, there's plugin JITs. So there's a lot of stuff happening there, but nobody's gone in the direction that you went in, right?
Yeah, it was an interesting. I mean, it's in a lot of ways it's kind of crazy. And the thing about Go, the Go runtime that Grumpy is based on, is that it is kind of designed for very similar use cases to what we're interested in. So Go tends to be used for writing highly concurrent server applications with a lot of like sort of message passing and things within the application between threads. It seemed like kind of a good fit, and once I started to flesh things out and to build out some of the core functionality, some of the pieces started to fall into place, and it started to look actually really compelling.
And you're like, hey, we could actually do this. We should stop for just a second. I don't think we've explicitly said your project is called Grumpy, which is a replacement for the C Python implementation with a entirely different Go implementation, right?
Yeah, that's right.
Yeah. So very interesting. I think, Go, obviously it makes sense for Google to be the ones experimenting with Go, right? Go comes from Google, doesn't it?
It does, yep. It was developed, I think, originally by, Rob Pike and I'm going to mix it up. It's either Ken Thompson or it's Ken Thompson, I believe. Yeah, it was developed for, I guess they had observed that, I guess similar to the observations that we made about running Python programs or Python server programs. They had made sort of more general observations about writing server applications and how languages that existed didn't quite fit what our use case is.
Yeah, Go is really it's one of the newest languages out there that I would consider a mainstream language.
Mm-hmm.
It's not as mainstream as C, but it's definitely getting there. It came out in 2012 in version 1, sort of officially.
Mm-hmm.
So it's born within this world of multi-core microservices, distributed cloud computing stuff, right? Yeah. Okay, so let's dig into what is Grumpy. Let's dig in a little bit, like how do I can take my Python code, I can write presumably some web app or something, a web service, and then I can run that on Grumpy. Like what does Grumpy do? How does it take my Python code and run it?
So Grumpy takes a little bit of a different tack than CPython. It's actually a transcompiler and runtime, whereas you can kind of think of CPython as like a virtual machine bytecode interpreter and runtime. And in that sense, it's kind of like a combination of Cython and a bundling of Cython and CPython, except that it's all in Go.
Right. So Cython takes a flavor of Python and then compiles it to C directly. And like C, Go is a statically typed compiled language.
Mm-hmm.
And so it's no longer interpreted. It's not even like JIT compiled like Java or .NET. It's full on compiled, right?
That's correct.
Okay.
So the sort of runtime side of things is actually like the correspondence is like this Python C API. There's actually a Go Grumpy API. And so what it's compiling is code that uses that API to mutate objects, to pull out state and those sorts of things. And so whereas CPython or vanilla CPython uses a bytecode interpreter to actually drive those API calls, the Grumpy and Cython are actually generating code that drives those API calls.
Okay. Yeah, very, very cool. Now, in your GitHub repo or the blog post, I don't remember where I got this, but you said it's intended to be a near drop-in replacement for CPython 2.7. How's that going? How far are you towards that goal? That's a pretty big set of APIs to cover.
Yeah, I'm learning every day, like how big Python is.
Nobody told me about this weird case I'm going to have to support.
Oh, yeah, totally. Yeah, I mean, I've been the amount of sort of spelunking I've done in CPython internals is I did not expect all that, but yeah, so it's going pretty well. The core functionality is there, so like the basic semantics of the language in terms of attribute access and how types work, and how method dispatch works. All of that functions basically fine. The basic types are all there, so lists and dictionaries and things all kind of work.
Do those mostly map directly to the underlying Go structures? Like, does a list in Python map to a slice in Go and things like that? Or do you have to do more complicated things to map it?
It's more complicated, and the reason is that Python is so dynamic, right? Like method dispatch is so dynamic, and attribute access, you can put attributes on just about anything. If it was just this native Go types, then you wouldn't be able to put an attribute on a list or on a slice, right?
Right.
So it's actually there's sort of wrapper types, basically structures that actually map very closely to CPython's object structures.
Okay, yeah, I can see that, because you're working with a non-dynamic language, and yet it has to support dynamic capabilities. So you got to somehow put a shim in there for that, right?
That's right.
Okay.
I guess the biggest kind of gaps in terms of supporting or being a drop-in replacement are the standard library still needs a lot of work. So CPython has a lot of its standard library is actually written as C extension modules, which Grumpy does not support. So that's one area of significant divergence between the two. And we can talk about that more. That's turned out to be sort of a big kind of beast to slay. The nice thing is that with all those other Python runtimes out there, there's actually you can find pure Python versions of most things, and so like PyPy, for example, implements a number of libraries that are in Python that aren't implemented in CPython.
Right. So you could say start this transition or this backfilling of APIs by just moving to pure Python implementations that then get sent through Grumpy that actually get compiled to run on Go, right?
Yep, that's exactly right.
And maybe do some profiling and say, well, people use list a lot. Let's write that directly in Go or something like this, right? You can optimize later.
Exactly. Yep.
Okay. Yeah, I suspect that there's a long tail of like stuff. This doesn't really need to be optimized, that last 5%. Whereas these are the few things that we really should focus on, right?
Yeah. So right now, I'm kind of focused on getting support for the whole. Like, I want to be able to run some common libraries that are written in Python. I want some Python programs that are out there, like open source programs, to be able to just use Grumpy. And so, like, just getting it to the point where everything runs is the first step, and then you make it fast.
Okay, yeah, of course. Making it work and then making it fast seems like the right order to me as well. So you said in your blog post that there's going to be some things that Grumpy will never support, and then there's things that it doesn't support yet, but you're working towards.
Yeah. So one of the things I mentioned already is the C extension support. The API for CPython is a bit different than the API for Grumpy because it's, well, for one thing, it's a different language, but also the data structures are a little bit different. The function return values and things are a little bit different. And so there wasn't a good mapping between those APIs, and it would be too constraining to try to make Grumpy map perfectly to the C API.
Sure. Have you looked at the CFFI stuff that PyPy was using?
Right. So that's, I have not looked very closely at that. That is something that we've looked at internally for other reasons as well. But that is an interesting way to approach the problem. And potentially, there are ways to bridge the two APIs that and CFFI may be one of those.
Yeah, okay. Does Go must have a C integration option somewhere, right?
It does, yep.
Yeah, okay. And the other thing you said it's not going to support is things like eval.
And again, this is like, it is possible to implement something that's a little bit hokey to support eval or exec.
Shell out and compile.
Oh yeah, exactly. I mean, like well, I mean, it's funny. You think about it, and like that's actually what Python is doing, right? Except that it's a bytecode compiler, and then it's executing in a VM. If you instead are actually doing an actual static compilation and then executing that, it's not conceptually that much different, except that the tool chain that you have to use to do the compilation stuff is much heavier. So it's going to be slower. And it kind of doesn't make a lot of sense. I think I could see maybe supporting it for, debugging use cases and things like that. I don't think I kind of want to avoid having to worry too much about making that performant or whatever.
Yeah, sure. I for one don't think I would miss it. I think it's fine.
Yeah. The other thing about exec and eval is there's very few cases I've ever come across in all my years of programming Python where exec or eval was a good idea. So actually, I kind of think that it's an unnecessary aspect of the language.
Yeah, that's interesting. And, it is kind of keeping with Go in the sense that Go is very strict about conventions and some of the best practices that it believes. Like, for example, if you have an import of a package and you're not using that package, that's a compilation error, right? Things like that.
Right, absolutely. Yep.
Yeah, so eval, skipping eval seems like that's all right. This portion of Talk Python to Me is brought to you by Hired. Hired is the platform for top Python developer jobs. Create your profile and instantly get access to 3,500 companies who will work to compete with you. Take it from one of Hired's users who recently got a job and said, I had my first offer on Thursday, after going live on Monday, and I ended up getting 8 offers in total. I've worked with recruiters in the past, but they've always been pretty hit and miss. I tried LinkedIn, but I found Hired to be the best. I really like knowing the salary up front. Privacy was also a huge seller for me. Sounds awesome, doesn't it? Well, wait until you hear about the sign-in bonus. Everyone who accepts a job from Hired gets a $1,000 sign-in bonus. And as Talk Python listeners, it gets way sweeter. Use the link hired.com/talkpython and Hired will double the sign-in bonus to $2,000. Opportunities knocking. Visit hired.com/talkpython and answer the door. Then you said there's a set of things that you're going to support, but it doesn't yet. What are those?
We talked a little bit about some of this stuff, but the standard library is not there yet. There's a subset of the standard library is available currently.
Can you give us a percentage of how far you are down that path? I mean, everyone listening, this whole project has been out on GitHub for 3 or 4 weeks. So it's not like you should have implemented it all. I'm just curious, how far you've gotten.
It's really hard to put a percentage on it. I guess, I probably could compare lines of code or something, but I think that what's going to happen is you're going to get sort of a core set of libraries that run all the other libraries and everything will just kind of fall into place. So I think it's sort of more important to count those core libraries and that's things like types and collections and operator and all those things. And some of those are already there. I feel like, yeah, it's hard to put a number on it.
Yeah, sure. Maybe it's one of those things where it seems like you're not very far and then all of a sudden it kind of unlocks and things go really quick.
That's the dream.
That's a good way to it's a optimistic view of the future, right?
That's right. If you're going to clone the repo off GitHub and try things out, you may be disappointed that your favorite libraries aren't there. There's a good chance that if you have a program that's at all complex, that there are some libraries that are missing for you. I'd say, I don't know, maybe 20% or something like that.
Okay. Well, that's good. You said you also want to support all the built-ins.
That's right.
Yeah, that's obviously a good idea.
Yeah, those are important. And again, there's a bunch of stuff that just hasn't, a bunch of functions like map and reduce and things like that I haven't haven't needed to support them yet. But they're actually pretty straightforward to implement by and large. So
Sure.
So I think we're pretty far along on that stuff.
So how much of your focus on Grumpy is going to be to make this a project that you guys could use for your specific use cases at Google, and then make that a skeleton or base, and people can come along and add other features and contribute to the open source project to make it more broad, versus how much are you trying to make this like we're trying to entirely replace CPython?
So I think that I want to see, okay, so I put it this way. I'm interested in, solving some of these concurrent use cases that don't have a great answer in CPython. That's the primary focus. But again, it might be my optimism is showing again, but like, I feel like once you kind of have some of those use cases locked down, now people start to use it for things you didn't expect right away. I know that like scientific computing is an area where Python has a really well-established libraries, and NumPy is sort of crucial to some of this stuff, and that's C, involves C extensions. And I think in the near term, I don't see Grumpy being useful for numerical analysis, and that's kind of compounded by Go doesn't have too many sort of inroads in that direction either. So, but on the other hand, some of the advantages of like being statically compiled and type inferencing and compiling down to native operations, that is potentially useful for scientific computing and those sorts of things. So I kind of see, I want to focus on our immediate use cases, but I have this kind of idea that there's more opportunities out there once things are kind of working.
Right. Okay. Yeah. That seems like a good roadmap to me. It makes a lot of sense. So let's talk about the execution engine, which effectively is the execution engine of Go versus CPython. So CPython, the Python code gets converted to bytecode. Those bytecode instructions are sent to like a super large for loop switch sort of thing, and those are interpreted and run. How does Go work?
Go has a runtime, which is to say that there's code that is running that's managing things like Go routines, which are the equivalent of threads in Go programs, and garbage collection and things like that. But much of what is actually happening throughout a Go program is actually, low-level machine instructions. So the
Sure.
Go program, much like a C program, is compiled down to machine code and actually executed natively.
Right. That makes sense. So you say Go has garbage collection, which is awesome. Do you know what kind it is? Is it reference counting, or is it like mark and sweep, or what kind of garbage? Is it deterministic? How's the garbage collector work in Go?
This is not my area of expertise.
Nor mine.
But it is not reference counted. So I believe that it is and actually this has changed significantly. I believe in 1.7, they significantly retrofitted the garbage collector. Mostly just around the way that garbage for particular Go routines is managed, garbage that is sort of local to particular Go routines. And but it's sort of a traditional, otherwise it's kind of a traditional garbage collector that much similar to what Java has, but it's actually much simpler. Java has a number of different algorithms it supports and a lot of tuning parameters. Go's garbage collection is much simpler and is targeted for the use case of handling requests in a server application and those sorts of things.
Yeah, it makes sense. I suspect they highly parallelize that, thinking of Go as well. One thing you said that's nice about executing ultimately on Go is you said the deployment story is a little bit simpler.
Python, when you deploy a Python program, you are actually including your like PY files, or at least your PYC files in the deployment. And so you have to have some way to sort of package them together and ship them off to production or wherever you're running your program.
Right. And beyond that, also the dependencies and the runtime, right? So you got to have all of those things.
That's right.
Which can make it really tricky. And there's things like Py2Amp, Py2Xe, CXFreeze, the Beware project. There's a lot of projects trying to make that something you can ship around, but it's not simple.
Yeah, that's right. And so I'm sure people who have run Python in production have run into, version mismatches, things like that, using the system Python version, which was, different than the one they were developing on and so on. The nice thing about statically compiled programs in general is that you produce a binary and you can put that just about anywhere and it'll run. And that's very true for Go programs. There's few dependencies. In most cases, most of the runtime is actually is actually linked into the executable.
Yeah, that's really cool. What's the size of like a Hello World compiled output? Do you know?
I have not looked at the size myself. I think I saw some comment somewhere that said it was something like 3 megabytes. So it's pretty substantial, but that includes a lot of overhead for the runtime that wouldn't increase significantly if your program grew.
Right, absolutely. Like, the next 10,000 lines add 10K or something.
Right, exactly, yeah.
I think 3 megs is totally fine to get a good deployment story, stability, you run what you shipped, all those things. Like, if this was 1994, 3 megs would be a problem, but it's not today, right?
Yeah, that's right.
Nice. So what sort of optimizations do you think are possible if you run Python on Go rather than as an interpreted system?
This is not an area I've dug into significantly yet. My thinking is that if you can determine that for example, a particular integer counter in a function is only ever an integer type and it only, uses integer operations like increment or whatever, then there's no need to go through the whole Python method dispatch and creating new integer objects every time you increment that counter. You can actually just use a native integer and increment using native operations. So that's a really simple example, but not uncommon. I think once you kind of broaden that to whole program optimization, that's when things start to get interesting, because then you can think about if you know that a function is only ever called with particular parameters or parameters of a particular type, then you can make some assumptions and again use native data types.
Sure. What about type annotations? And I know that's more a Python 3 thing, but would you be able to or interested in having some flavor that takes type annotations and then uses that for certain types of optimizations?
Yeah, I thought about this and I'm a little ambivalent because, type annotations, the way that they are sort of used today, they're not intended to actually, raise or anything if they're not respected. It's mostly for analysis before you ship your program to make the linter's job easier and things like that.
Right.
And so once it actually in CPython, once your type annotations, once you're actually running your program, the type annotations basically have no effect. And so I'm a little hesitant to say that Grumpy should use these in sort of a more strict way, because I think that might affect programs' compatibility and stuff like that.
Yeah, it will absolutely do that, wouldn't it? Yeah.
There's some real advantages there. If you do make them strict, then you say that an argument is an integer, then yeah, it makes the optimizer's job way easier, because it can, it doesn't have to do any inferencing to determine that relationship.
Obviously, it would break the sort of contract with type annotations that these are just for editors and linters and to help you, but not actually meant to affect the runtime.
That's right.
On the other hand, if you could make some part of code that's really critical go 10 or 100 times faster by putting a type annotation that's strict, you might be willing to make that trade-off. So I don't know which way would be the right way to go either, but it's interesting to think about.
Yeah, I'm very curious how that sort of evolves.
Yeah. I'm going to keep an eye on it. That's cool. So let's talk about when you launched. So this should be pretty fresh in your mind, right?
Yeah.
It's not a very old project.
It's about a week and a day.
Yeah.
Yeah, so I guess we migrated the code to GitHub in mid-December, and I spent some time over the next month kind of cleaning up, or the next few weeks cleaning up the code and adding some functionality for the build system that we were not able to use, obviously, the internal Google build system in the open source project. So I had to build some of that out. And then I guess January 4th. Yeah, I guess it was the 4th.
That's 8 days ago, just for the day of the recording, yeah?
Yeah, we did. We sort of coordinated an open source blog post with the actual making the GitHub repo public, and got a little bit of traction on Hacker News. And yeah, it was kind of astonishing how great the reception was.
Yeah, it's going like crazy. Like when I took notes for this conversation like 4 or 5 days ago, I had said there were 5,000 stars in GitHub. Now, maybe that was 3 days ago. Now there's 6,000, almost 6,300, 17 contributors. That's a pretty serious uptake for a project that's been out for 8 days.
Yeah, I think the thing that kind of blew me away most was the number of pull requests that I got. I mean, right on day one, people were digging into the code and, doing like the code. There are tricky parts to the code, and it's not necessarily obvious how you ought to write certain features. And people, really dug in and started filling out some of this functionality that's missing, and started talking about, well, how are we going to support programs or libraries, third-party Python libraries out of the box and stuff like that. So it's been great. I've had a really good time working with some of these people that have been contributing.
Yeah, I would say that's really cool. You talked about the code a little bit. Looking on GitHub, GitHub thinks it's 77% Go code, 22% Python code, and a bit of a makefile.
Yeah.
Does that sound about right?
Yeah, that's about right. And a lot of that Python code is actually just tests and benchmarks and things. So most of it is Go. And actually, I guess the standard libraries, most of which are copied from other places like CPython. There's a pretty substantial amount of Python, but that's not like, I don't think about too much about that code since we don't have to write it or maintain it.
Yeah, absolutely. So how do you ensure compatibility in this? Like, are you running the standard CPython tests?
That's something that we're working to. So that's sort of milestone number one. I haven't published a roadmap document yet, but getting to the point where we can run the unit test library is going to be a huge milestone, because it means we can then run the unit tests that are written for CPython.
That would be a huge milestone just on compatibility.
Exactly. Before we get there, we've been writing small tests to that, demonstrate compatibility concerns and stuff like that, and then running those in both Python and Grumpy.
Okay. Yeah, very cool. So let's talk about why you chose Go, because are there 3 sort of officially blessed languages at Google? There's Python, there's Go, and Java. Is that
and C++? Is
that the story these days?
Yeah,
right. Of course, and C++. So 4. So why did you choose Go? Like, you could have tried Jython or something, right? Jython
is something that we've looked into. Jython's a really great mature product. It's our experience that it's better to start a project on Jython than to migrate to Jython. There's a number of compatibility issues, not so much like the kinds of compatibility issues like, on CPython, this function returns a different type or something like that. More that there are certain constraints of running in the JVM that make certain programs not work very well, or those sorts of things. So like performance issues that sort of crop up and those sorts of things.
It sounds like running on the JVM was not the best concurrency server story as it might have been running on Go, because Go is more focused on concurrency from the beginning, things like that. That might be more important to you guys?
Yeah, I think that was part of it. I mean, like lightweight Go routines are definitely a big advantage to Go. So Java has native threads, which have large stacks. And so it has sort of a different performance characteristics for concurrent workloads. And so you have to kind of write programs, parallel programs in a slightly different way for Java. But also for real-time server applications, the JIT actually can be a liability. It becomes difficult to reproduce certain kinds of issues, debug certain kinds of problems, and consistency, because consistency of how requests are handled is really important in these kinds of applications. And the JIT can make identical requests behave very differently depending on where in the lifecycle the program is.
Sure. Yeah, that makes a lot of sense. Being statically typed, you get a little more predictability.
Absolutely.
Well, not statically typed, compiled to like machine instructions rather than to JITs. Yeah.
Yeah, that's right. Yep.
Hey everyone, let me take just a moment and tell you about a new sponsor with a cool and timely offer. This portion of Talk Python to Me is brought to you by Deep Learning for Computer Vision with Python, a new book from PyImageSearch.com launching on Kickstarter right now. Have you ever wondered how Facebook can not only detect your face in an image, but also recognize and tag you as well? It's not magic. Facebook uses specialized machine learning algorithms called deep learning, and PyImageSearch wants to pull back the curtain and show you how these algorithms work. Their new book is designed from the ground up to help you reach expert status, even if you've never worked with machine learning or neural networks before. Inside Deep Learning for Computer Vision with Python, you'll find super practical walkthroughs, hands-on tutorials with lots of code, and a no-fluff teaching style that is guaranteed to cut through all the cruft and help you master deep learning for visual recognition. To learn more about this book and back the Kickstarter campaign, just head to PyImageSearch.com/Kickstarter. Yeah, so how do you run apps on Grumpy? Like if I have Python code and I want to make it go, how do I make it go on Grumpy?
This is sort of a hot topic right now in the issue tracker on GitHub, because like the build system that I have and is strictly focused on getting the internal libraries working. And so it doesn't have good support for building a program that's outside that directory structure or using libraries that are in your Python path or anything like that. And so we're debating kind of how exactly it should be supported. So right now, if you want to run a program or compile a library, you have to kind of drop it into that directory structure, and the make system will pick up on it and try to compile it into Go. But ideally, you have some kind of Python path style construct where it can find Python code and build it in a sort of standard way. That's something that we're working towards.
Okay, cool. Now, if people want to contribute to Grumpy, there's like three major areas that make it up. You want to talk about those three areas so they maybe can use it as a roadmap?
You can kind of think of it as the transcompiler, which is the tool called grumpc, and that takes Python code and it actually it's written in Python and it uses the AST module. So it's kind of cheating. Another milestone will be when grumpc can compile grumpc. And that takes the Python code and spits out some Go code. And then the second part is the Grumpy runtime, which is kind of the parallel of the C API. The transcompiled Go code will depend on that runtime. So it imports the runtime and uses the constructs and functions and things in the runtime. And so that's another sort of component that's written strictly in Go. And that's where all the sort of data structures and things are defined. And finally, there's the standard library. That is mostly written in, or actually exclusively written in Python, but also uses some of the Grumpy native extensions to actually interface directly with Go packages and functions and things. So there's sort of the three areas, and there's a lot of work to do in all of those different areas. I'd say like the standard library is the biggest chunk of work to do at this point.
Presumably, you guys chose Go because of the concurrency story, right? And if you have Python code running on Go, you want to leverage that concurrency. Do you have to use a different API? This is Python 2.7, so you don't have things like async or wait. How do I interact with the concurrency model of Go?
Currently, the way that Go routines are made available is through the threading library. So the standard Python threading library, you create a thread and start it, and that actually starts a Go routine instead of a native thread. That will work pretty seamlessly with existing code. I don't foresee huge problems there in terms of like the differences between those kinds of threads. And again, Go has the concept of channels, which are sort of a message passing mechanism, and Whereas in Python, you have a queue, the queue data structure, and this isn't actually implemented, but I plan to implement a queue using channels. And so you should be able to just write concurrent Python code like you always have. But I think to really take advantage of sort of the concurrency model, you probably, eventually I'd like to implement the async and await Python construct. I think that would be a huge win.
Yeah, that would be a huge win. And it seems to me like using the threading API is much more coarse-grained concurrency than Go is really built for. And while it would work, it's not taking full advantage.
The idea with Go is you can start a Go routine, or starting a Go routine is extremely lightweight. And passing messages back and forth is the way to sort of share state rather than with sharing memory or sharing objects. So I think that programs that are written with sort of heavyweight threads in mind aren't necessarily going to be the best possible way to express that functionality. And so, long term, I could see, actually, because you can access native Go constructs, for example, you will be able to, in a Grumpy program, use Go channels directly. That has upsides and downsides. It starts to diverge from the Python language and those sorts of things. But
it's not unlike IronPython or Jython or those things, right? Where you can reach down into the underlying JVM or CLR or something like that.
That's right. Yep, absolutely.
Okay. So if you're going towards async and await, what's the story on Python 3? Since I feel like the threading concurrency story is a lot better in Python 3.
Yeah, I'd love to support Python 3. The long-term goal is definitely to support it. The reason for 2.7 is that YouTube had a large existing Python code base, and that was 2.7. So that was the main reason for choosing 2.7 out of the gate. But certainly long-term, I'd like to see all Python 3 supported.
Right. Oh, that'd be fantastic. I'd like to see that as well. I mean, it certainly makes sense if you're working on the YouTube team. YouTube has a tremendously large and widely adopted deployment of Python 2.7. Like you want to, work where you can have the biggest impact locally, right?
Absolutely.
Yeah. So reading the tea leaves, does this mean that Grumpy might someday run YouTube?
I want to hedge a little bit on that. I think there's a sort of a long road ahead before Grumpy's ready to handle the kinds of large applications that we run at YouTube. So I wouldn't want to speculate about the long-term outcomes there.
Sure. Yeah, of course. Let me just let's imagine a world where it did. That would be probably the first few weeks that it switched to Grumpy would be a little bit nerve-wracking, right?
Yeah, it would definitely.
If YouTube goes down and it's your fault, that's going to be a problem.
Yeah, exactly. I don't want to be that guy.
Exactly. Here's the 4 pages we're giving you. No, just kidding. But it would, if someday that came to be, that would be a really cool outcome of this project.
Yeah, absolutely. That's sort of the dream.
Excellent. Okay, so maybe that's a good place to leave it. Let me ask you just a couple questions before we let you out of here. If you're going to write some code, what editor do you use?
Vim.
Vim. All right.
Yeah.
Very cool. And there's over 96,000 packages on PyPI these days, and I'm sure you've come across some that are kind of unique. You're like, hey, have you heard about this package? It's pretty cool. You should check it out. You got any coming to mind?
It's funny. I mean, because I do a lot of most of my development inside Google, we kind of have a different set of tools we tend to use. I don't have a ton of experience with a lot of PyPy packages.
Yeah, so it's a little bit more dark matter. We out here in the larger universe don't get to see a lot of the cool stuff you guys get to use. I'm sure it's pretty neat, though.
Absolutely.
All right, awesome. So how about a final call for action? Like, how can people get started with Grumpy? What can they do if this resonates with them? Things like that.
Yeah, I mean, we're super interested in seeing where the project goes. I don't have, like I said, I would like to see where Grumpy can be useful besides just large concurrent server applications. Community feedback around that is great. People have been filing issues asking about support for different things, and that's been really illuminating, seeing where people are thinking about where this might be useful. So that's huge. If you have the time and the inclination, try it out. Just clone the repo and type run and try out Python and Go and report any issues, that's really useful to us. And obviously there's a ton of work to do. We talked about some of the different things, and contributions via PR, pull requests on GitHub are really appreciated. It's been kind of amazing how much effort people have put in already. So that's been really exciting for us.
Yeah, it's a cool project, and I think if we have yet another powerful, flexible runtime that has some different trade-offs that we can make for Python, that's great for everyone. So congratulations on your project, and thanks for sharing it with everyone.
Yeah, thanks very much, Michael.
You bet. Talk to you later. This has been another episode of Talk Python to Me. Today's guest has been Dylan Trotter, and this episode has been sponsored by Hired and PyImageSearch. Thank you both for supporting the show. Hired wants to help you find your next big thing. Visit hired.com/talkpython to get 5 or more offers with salary and equity presented right up front, and a special listener signing bonus of $2,000. Struggling to get started with neural networks, deep learning, and image recognition? PyImageSearch.com can help with that. To learn more about their new book, Deep Learning for Visual Recognition with Python, and back the Kickstarter campaign, just head to PyImageSearch.com/Kickstarter. Are you or a colleague trying to learn Python? Have you tried books and videos that just left you bored by covering topics point by point? Well, check out my online course, Python Jumpstart by Building 10 Apps at talkpython.fm/course to experience a more engaging way to learn Python. And if you're looking for something a little more advanced, try my Write Pythonic Code course at talkpython.fm/Pythonic. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find the iTunes feed at /iTunes, Google Play feed at /Play, and direct RSS feed at /RSS on talkpython.fm. Our theme music is Developers, Developers, Developers by Corey Smith, who goes by Smix. Corey just recently started selling his tracks on iTunes, so I recommend you check it out at talkpython.fm/music. You can browse his tracks he has for sale on iTunes and listen to the full-length version of the theme song. This is your host, Michael Kennedy. Thanks so much for listening. I really appreciate it. Smix, let's get out of here.
Stating with my voice, there's no norm that I can fit within. Haven't been sleeping, I've been using lots of rest. I'll pass the mic back to who rocked it best. Developers, 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 developers.